This is 4.4 Laws of Logarithms. So you should have covered these laws in a previous class, but just to refresh your memory. So if you have log base A of AB, well, that's the same thing as log A plus log B. And then the same thing with log base A divided by B, that's the same thing as log A minus log B. And then log A raised to the C power is the same as C times log A. All right, so let's look at some examples of those. If you need to pause the video to write these down, do that. But these laws of logarithms are going to be used to help us solve some, do some calculations, but also helps us solve some word problems. All right, so if I had to evaluate this, well, notice this is log base 4, log base 4. So something I didn't emphasize based on the, just let me go back and go back to the laws of logarithms. Notice this is base A, base A, base A. So they're all the same base. I just want to keep that in mind. Sometimes I don't, teachers may not say that, but this is assuming that the same base. So log base 4 of log 2 plus log of 32. Well, notice I can combine these guys together to be log base 4, and then the plus sign is the same as multiplying. So this would be 64. And again, to evaluate that, remember what that means is if you go counterclockwise, we're trying to evaluate that. So 4 raised to some power gives us 64. And well, that's 4 cubed. So x equals 3. All right, so that's what we're trying to find. So this literally equals 3. Log 2 plus log 32. Base 4 is actually the answer 3. All right, let's look at another one. So here again, the bases of log base 2, and then I have 80 subtract 5. Well, that's the same thing as log base 2 of 80 divided by 5. Well, and then if you reduce that, that's the same thing as log 2 of 16. And again, if I evaluated that, I'm looking for some number, 2 to some number, gives me 16. Well, I know that's 2 to the 4. So I know this answer is 4. And again, if I had this evaluating problem of logarithms, remember when I have multiplying a number on the outside, that's the same thing as, like literally I could take log 8 of negative 1/3. And then you can get, remember, a negative exponent means to flip, and to the 1/3 power, that's the same as the cube root. So literally, 1/3 power 8, that's literally the same thing as the cube root of 8. And then, but I'm going to flip that. So the cube root of 8 is 2. So I'm going to literally flip that. So 1 over the cube root of 8, which is log of 1/2. And then to evaluate that, we're going to take log 0.5. And so this approximately equals, depending on, let's say 3 decimal places, so negative 0.301 approximately. All right, and just so you know, look what I just did on the calculator. You could have actually plugged this into the calculator to begin with, and you would have ended up with the same answer. But if I ask you specifically to use the law of logarithms to be able to evaluate that, that's the work that I would be looking for to be able to do that. Even if you just got it down to this step right here without the use of a calculator, you're showing me you know the laws of logarithms. All right, so let's go backwards now. Let's actually expand this. So here I have log of parentheses 6 plus x, or 6 times x. So that means literally that log of 6 plus log of x. And I do want to emphasize that the base is 2. So both of these are base 2. And that's all that I'm looking for. You know how to use the laws of logarithms, so I would expand that. So here again, I have a multiplication problem. And so I have log of x cubed plus log y to the 6. And then there's also another log rule. Remember, anytime I have an exponent, that's the same thing as bringing it out front. So this is 3 log of x, and then 6 log of y. And then again, I want to go back. I always do this at the very end, but this is base 5. So these are all base 5s. So don't forget that as you go along. Big difference. If you left it blank, remember that's log base 10. So you need to make sure you include that base. And then finally, our last problem here. So we have a natural log, and again, that's the same as log. Same laws of logarithms. So here you have literally a division problem. So literally you have ln of AB minus ln of the cube root of C. Well, notice this right here is a multiplication problem, so that's literally ln A plus ln B. Now this right here, remember that the cube root of C is the same thing as C to the 1/3. And so if I had C to the 1/3, I can bring this out, the 1/3 out, the exponent out front, and then ln C. So this is expanding the entire thing. All right, so now let's kind of put it all together in a problem that I ask you to combine all this. Well, look at it as a separate problem. So this could be ln x of x cubed. Remember, the exponent can go up front. Same thing here. This is ln of y to the 1/2, which is the same thing as the square root of y. And notice here you have of just ln and then parentheses y squared plus 1. And again, it's not the distributive property, so don't make the mistake. I've seen it before. Don't do this. ln y squared plus ln 1. Do not do that. It's not the distributive property. Don't do that. All right, so it's the natural log of the entire y squared plus 1, so it's not the individual natural log. All right, so again, if we combine this together, remember the plus sign it means multiplication, so we're going to do ln. I keep wanting to write an H for some reason. So ln, I'm going to multiply those together, so x cubed, the square root of y. And then subtraction means division, so I'm dividing it. Notice what I'm doing is I'm taking 3 logarithms, natural logarithms. I'm taking 3 natural logarithms and I'm combining it to 1. That's really what combining is. I'm combining it to 1. All right, so let's look at, and I kind of mentioned this on the last thing, some common mistakes that students tend to make is, logarithm, they tend to want to use the distributive property. That's a common mistake, so you can't actually do that. So just keep that in mind, that's a common mistake. So this literally can't be simplified just by any laws of logarithms. And then the same thing here with division. So a lot of students think that the logarithm of a division problem is the logarithms of each one individually divided. So that's not true. So again, those are common mistakes. Make a strong mental note of that. Make sure you don't make those same mistakes. All right, and then one last thing is the change of base formula. So here we have log of base b of x, and that's the same thing as log of x divided by log of b. And here's an example. So if I ask you to calculate log base 5 of 7, well, that's the same thing as log of 7 divided by log of 5. And then you can just plug that into your calculator, log 7 divided by log of 5. And then you better get your answer. Now again, some calculators, like the calculator I'm using, I know it can actually type that in, but most of the scientific calculators can't type that in exactly, and that's why you use the change of base formula. Or if you have a TI-83, you can't do that either. So the change of base formula comes in very handy to be able to calculate any type of logarithm, any base. So that's the change of base formula.